Hello everyone, welcome back to my channel. If you are new to this channel, hello, my name is Shagun and you are watching Learn with Shagun. So in this video, we are going to do the mechanism of nucleophilic substitution in square planar complexes. So it is a very easy topic, I would say, and very easy to understand also. So what just happens is, what is a nucleophilic reaction first of all? So nucleophilic reaction, all of us know, is a kind of reaction in which an electron loving species substitutes one of the ligands or constituents of a metal complex, which is easy to be substituted, in a electron deficit species. Okay, so such kind of reactions are called nucleophilic substitution reactions. Okay, what entering species can perform a nucleophilic substitution? The species which itself is rich in electrons, or an electrons rich species can only do it. Okay, so this is the basic. Now the substituent which gets replaced, for example over here, this is a complex, the Y is the electron rich species which has come to substitute a particular constituent of this metal complex, which is electron deficit. The component which at last gets substituted is known as the substrate. Okay, so let us move into the depth of it, the mechanism of nucleophilic substitution reaction. So what do they say is, they say that since the reaction involves a bimolecular displacement, so what happens that in a nucleophilic substitution for square planar complexes which are in a square planar shape, okay, geometry. So in such complexes, the substitution proceeds most readily by an expansion of the coordination number. Now what happens is, see here, the coordination number is 4, right? Now when a ligand approaches, or other I can say substrate approaches, coordination number expands. How? From 4 it became 5. This also got added on over here, right? The y. Now the geometry became square pyramidal, okay, which is very less stable, and it has a coordination number of 5. For coordination number 5, you must have rarely heard the name of the square pyramidal geometry. So it is very less stable. That is why now tautomerism happens. What happens? Rearrangement happens. Look carefully towards this step. So rearrangement happens right here, in which the Y takes an equatorial place along with the X and T, and L and L ligands are present in the axial position. Okay, so now this complex is called as the activated or true intermediate, because this was very less stable. This is quite stable, so that is why it is called the activated complex or the true intermediate. So these are the first two steps. The square pyramidal geometry changes into a trigonal bipyramidal. Now let us revise the first two steps. It was very simple. What just happened, there was a square planar complex. Okay, so the metal which is constituting this square planar complex, it is having D8 configuration, and it has a vacant pz orbital which is of lower energy and which can easily accommodate any of the electron pairs but donated by any of the ligands. So if such ligand approaches it which is electron rich, so pz orbital, what will the pz orbital do is, pz orbital will easily accommodate the electron pair which would be donated by this only. Okay, there is no contribution of this metal. Coordination chemistry we are studying, right? Now what happens next is rearrangement. Tautomerism occurs, in which the square pyramidal, which was very less stable, got converted into a stable intermediate, which is called the activated complex or the true intermediate, which is a trigonal geometry of it. Okay, now what just happens, again a kind of rearrangement occurs. Nothing added on, nothing got lost. Now it again takes a square pyramidal shape. Okay, it rearranges, and the X from this bond gets detached from the metal complex, and it forms the substrate and gets detached. Okay, so what they are saying is, as X departs from the trigonal plane, what was the trigonal plane? This was the trigonal plane. Okay, Y, T and X were in the trigonal plane. So what they are saying is that as X departs from the trigonal plane, the TMY angle will open, and geometry will pass through a square pyramidal. Again, when it will open, it will pass through pyramidal geometry. Okay, to square pyramidal intermediate to square planar product, okay, which is the final product which we got with the release of X. It was having only 4 steps. Okay, adding on of an electron rich species to a square planar geometry complex, and which was having a vacant pz orbital. Okay, such kind of square pyramidal complex which was very less stable was formed. Okay, now it rearranged to give an activated complex which was having a trigonal bipyramidal geometry. Again passed through a square pyramidal geometry and at last the X got detached, and again a square planar complex is formed, but now at the place of X we are having Y. So the mechanism you studied right there was without the involvement of any solvent. Now let us see that if we are performing this nucleophilic substitution in a square planar complex with the help of a solvent, what happens. So let us study a solvent-assisted mechanism. Okay, now this mechanism is just similar to the first mechanism that we studied right here, which was without any solvent, but it is having 2 more associative steps. Here the first step was the substituent donated the electron in the vacant pz orbital and got attached to it. Now what happens over here in this mechanism is the substituent is not added on first, the solvent gets added on. The solvent gets added on to the square planar complex. Okay, now it forms a square pyramidal geometry. Now in the second step the substituent is added on, which is Y. Okay, now Y is added on. What happens is in the very second step the X gets detached. Okay, and solvent takes the place of X over here through rearrangement, and Y gets attached to the complex right there. Now again we have studied that square pyramidal is a less stable geometry, so it gets converted through tautomerism or rearrangement into a trigonal bipyramidal geometry. Got it? S is present in a trigonal plane now. Now when X departs from this trigonal plane, the geometry passes through a square pyramidal geometry, and now ultimately this gets detached from it. It departs from the complex, and ultimately we get a square planar geometry in which Y is there in the place of X. The nucleophilic substitution has taken place. So this is it for this video. I hope you found something useful in this video, and